So we're going to continue on with this section, applying the double and half angle formulas. We walked through a lot of the half angle ones yesterday, finding that half angle and then solving them. Today, same idea, but it's just going to be a little bit different. These ones say to find the exact values for sine of a over 2, cosine of a over 2, and tangent of a over 2. And you're given something like this. Cosine of a is equal to 4 over 5 for 0 less than a less than pi over 2. So we want to think about what quadrant this falls in first. Okay. Okay, there you go. Quadrant 1. Okay, so it's in quadrant 1, so that's where I'm going to draw it. I'm still going to treat this just like I would normally treat cosine to be adjacent over hypotenuse. So I'm going to draw my little triangle here. Actually, let me do it in a different color. So my adjacent side is 4, hypotenuse is 5. Do y'all know what the other side is? 3. Do you remember that, or did you do it?
I remember.
Okay, good.
It's a Pythagorean triple.
3, 4, 5. All right, so then we want to find what the sine, cosine, and tangent values are for this angle. Okay, we already were told cosine, but sine of A would be 3 over 5. Cosine of A, again, that one was given. And tangent of A is 3 over 4. Okay, so we're going to take this. Okay, you've got all the setup that you need now to solve this. So we're going to use those and plug them into the formulas, basically. So we're going to start with sine of A over 2.
How much space do we need?
Like probably 8 lines, depending on if you write sideways or down. So, all right, so sine of A over 2. Okay, what's the formula for sine of A over 2?
1 minus, well, it's all under the radical. 1 minus cosine A over 2.
So then we're going to replace cosine of A with 4 over 5. So since it's going to be over 5, I can go ahead and rewrite this 1 as 5 over 5. Minus cosine of A is 4 over 5, all over 2. So then I can, because I'm dividing by 2, I can, like when I do this, I can multiply by 1/2 instead. So 5 over 5 minus 4 over 5 is 1 over 5 times 1/2. Okay, again, because I'm dividing by 2. So then this is equal to the square root of 1 over 10.
Having a phone on him.
That's great.
Hey, what am I supposed to do?
Put it on something.
Is it somebody you know?
No, but it's one of my dad's workers.
Impersonate.
Just
Yeah.
let it go to voicemail.
He doesn't know.
How do you do? What are you supposed to do?
Give it to me. I know how. Wait, never mind. Yeah, it is an Android. I don't know how to turn my Android off on the next.
Oh.
That's great.
Yeah, like it was Josh, Android user.
Solo
Androids
Android.
are better.
Debatable.
In some ways.
Okay, so remember this is the same thing as the square root of 1 over the square root of 10. Okay, the square root on the 1 just goes away. Can't leave a radical on the bottom, so what is my final answer?
Root 10 over 10.
Root 10 over 10. Okay, so the sine of A over 2 is equal to root 10 over 10.
So why couldn't you? Never mind. Just
All right, cosine of A over 2. What's the formula for that?
1 plus cosine A over 2 radicals.
make sure you get the right
So same thing, I'm going to replace the 1 with 5 over 5 just to go ahead and get that common denominator. So 5 over 5 plus 4 over 5 all over 2. So then that's going to be 9 over 5, and I'm dividing by 2, so I can multiply by 1/2. So this is going to end up giving me, I'm going to go ahead and split my radical just to save a step. So it's going to be the square root of 9 over the square root of 10. So what's my final answer going to be?
3 square root of 10 over 10.
3 root 10 over 10. Okay, so if you want to write out all the steps, like when you do it, completely fine. I'm just trying to save you a little bit of writing if possible on stuff like that y'all have done for a while. All right, tangent of a over 2. Formula.
Let me see, I forgot it.
There's 1 minus
Well, pick your
cosine.
favorite one. What?
1 minus cosine A over sine
So, again, I'm going to replace 1 with 5 over 5. So 5 over 5 minus cosine of a is 4 over 5, all over 3 over 5. So on top, I have 1/5 over 3/5, or all over. So then, now what?
You multiply by the reciprocal.
Multiply by the reciprocal, so that's going to be 1/5 times 5/3, which is going to give you 1/3.
Yeah. It's like they're not hard. It's just so
Time
much
consuming.
to do.
Yeah. They're not, like, yeah, they're really not bad. It's just, like, very time consuming. So, I'm not going to assign you a lot to do, but if you're, confused, do more. It's going to take you a hot minute to do them, so. All right, so do y'all want to see another one like this?
Is it more difficult or is it just
Basically, 14, because there's only 4 of them in this section, so that was 12. 14 is just going to fall in quadrant 2, meaning you're just going to have some negative values, but that's the only difference with it.
Good.
Are we okay?
Anything
Good.
else?
Okay. I don't mind doing it. They are time consuming, so if y'all are like, no, I get it, there's no need to keep doing it. And we've done a lot with the half angles. All right, so now we're going to do it the same thing, but with double angles. Okay, so now we're going to be, instead of finding sine of a over 2, cosine of a over 2, blah, 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 we're now finding sine of 2a, cosine of 2a, tangent of 2a. Okay, so same thing, the way we set this one up, we're still going to draw this the same way, all that stuff, and then you're just going to use your double angle formulas to do these ones. Not really going to matter for the ones that have multiple formulas, which one do you pick? So you can pick your favorite one, I don't care, but anyways. So 18 tangent of a is equal to minus the square root of 3. And it's from pi over 2 less than a less than pi. Okay, so this one will end up getting set up the same way as the other one did. I can't remember, it's been obviously a year, but sometimes I may just tell you, I may give you one setup and tell you to do the half angles and the double angles all for the same problem, just so it keeps you from having to set up 2 different problems. Just make sure you read instructions if I do that. I don't know. Just be prepared for that in case. All right, so where's this one?
quadrant 2?
Okay, it's in quadrant 2, so it's going to be over here. So tangent is opposite over adjacent, so that means that square root of 3 is here, but obviously that's a positive y value, meaning my x value has to be -1. Now Now I'm going to see if you remember your special triangles. You don't remember a 30, 60, 90 triangle?
Oh.
The side
Yeah,
values
yeah.
are?
Bad.
Is that a 2?
Is it? Yeah.
1, 2, root 3. Okay. You obviously could have found it the normal way too, but. All right, so I want to go ahead and list off my values. So sine of A would be what?
Root 3 over 2.
Root 3 over 2. Cosine of A.
Negative 1 over 2. Negative
And tangent of A.
root 3 over.
Oh yeah, they gave that one to you.
Oh.
I wasn't trying to. Just kind of got distracted. All right, so double angle formulas, little easier to plug stuff in because you don't really have the fractions, or at least not as bad. So formula for sine of A, or sine of 2A, I should say.
2 sine A cosine A.
2 sine A cosine A. So then just plug the stuff in. So 2 times sine of A is root 3 over 2. Cosine of A is negative 1/2. So I can cancel 2, 2, maybe negative root 3 over 2. These ones you probably will like the math a little better for. A little less work. Cosine of 2A.
Let's do 1 minus 2 sine squared A.
Okay. So remember when I have something like this sine squared of A, I can think about this as the sine of A squared. So that's how I'm going to write the value when I plug it in. Okay. So 1 minus 2 times sine of A is root 3 over 2. And that whole thing's getting squared. So then that's 1 minus 2. And then the square root of 3 squared is just 3. And then 2 squared is 4. So this 2 and the 4 can cancel. So you end up with 3/2. So you can rewrite your 1 as 2 over 2 minus 3 over 2. It's negative 1/2.
Why is it?
I don't know. Who knows? Is it bothering you?
No, I'm just like really confused.
Is that better, Nathan? All right, tangent of 2A.
2 tan over 1 minus tan A.
All right, so tangent of A is minus root 3. So 2 times negative root 3 over 1 minus a negative, so plus root 3. So that's, just so we see it, negative 2 root 3 over 1 plus root 3. So now what am I going to need to do with this one?
Wait. Oh, actually, because you have a radical on the bottom, okay. So you multiply the top and bottom by 1 minus root 3.
Is that called a conjugate?
Yep.
That's in English too.
That's a conjugation.
We don't talk about English in this class.
Yeah, the conjugated form of the word.
All right, so on top, that's going to give me negative 2 root 3 plus the root 3's, when they multiply together, just going to give you 3. So 3 times 2 is 6 over. On the bottom, that stuff allows it to cancel, so you get 1 minus 3. So So then negative 2 root 3 plus 6 over negative 2. Now what?
Cancel out.
Divide by 2.
But you gotta
Okay.
You can't wait.
So I can take a negative. I'm going to get rid of my negatives because I want that, like,
Yeah.
gone. So I'm going to take a negative 2 out of the top. So negative 2 times root 3 minus 3 over negative 2. And then it allows that to cancel so that I finish with root 3 minus 3. Okay, now if you didn't take the negative out, like, I'm not going to take off for not taking the negative out, but it just makes it nicer because there was a negative on the bottom as well. So it goes away.
If you didn't take the negative out, wouldn't it just end up being positive? Because there's
Yeah, it would, but. All right. Do you want to see another one of these double angle ones? Or are we okay?
We can do another one.
Yeah.
All right. So then 20 cosine of A is equal to 2/5, and it's from negative pi over 2 less than A less than 0.
It's in quadrant 4.
I really wasn't sure what you were doing.
I
I
was
was
doing
like,
this.
what? I was like, why are you doing that? And I was like, oh, you're telling me what quadrant it's in. All right, so it's in quadrant 4. So cosine is positive, hypotenuse is positive. All right, so adjacent is 2, hypotenuse is 5. It's the other side.
Do we actually have to do the formula?
I mean, you can do it in your head. I don't really care. 5 squared is what?
25.
Minus 2 squared.
21.
Okay, so then the square root of 21.
Well, I just wasn't sure if this was like.
No, it's not a special one. I just don't feel like writing down the Pythagorean theorem. All right, so sine of A is what?
Root 21 over 5.
And tangent. You need to learn how to silence that.
That happened in Friends class. How in the world?
If it happens in Mrs. Madden's class.
Or Miss Marshall's class, you're
Yeah,
done.
You're done. It's over for you.
Oh my god. It'd be good now.
It should be.
Tangent is what?
Root
21.
21 over 5. I mean 2.
All right, so now sine of 2A is equal to
2 sine A cosine A. Right? Yup.
so 2 times square root of 21 over 5 times 2 over 5. 4 root 21 over 25. For cosine, pick a different one this time than you did last time. Just so we can use something different.
Oh yeah, I forgot there was multiple.
And don't forget, you do have to have all those formulas memorized.
Cosine squared of A minus sine squared of A.
Alright, cosine squared minus sine squared. So 2/5 squared minus square root of 21 over 5 squared. So that's going to end up giving you 4 over 25 minus 21 over 25. What was that? Negative 17 over 25?
Yeah. Weird numbers.
And lastly, the tangent of 2a.
2 tangent A over 1 minus tangent
So tangent is square root of 21 over 2. So 2 times square root of 21 over 2 all over 1 minus the square root of 21 over 2. Now on top, that kind of works out nicely for me because stuff's going to cancel. I literally canceled them.
A.
Come back. Hello. There we go. Come on. All right, 2's cancel. So that leaves you with the square root of 21 over, I can rewrite the 1 as 2 over 2. So 2 minus square root of 21 over 2. Now what?
There's like technically a radical on the bottom.
Yeah, but I want to do something
Cancel out
first.
the 2's.
Can't do that. Can't
And-
cancel the 2's because there's not a 2 attached to the square root of 21. Dividing by a fraction, so what should I do?
Multiply by first.
So square root of 21 times 2 over 2 minus the square root of 21. And no, the square root of 21s can't cancel. Because I foresaw that question coming.
I've learned. I wasn't going to ask.
2 square root of 21 over 2 minus square root of 21. Now
we
what?
Multiply top and bottom by 2 plus square root of 2.
Yep, I got you.
Yeah.
All right, so that gives us 4 square root of 21 plus 2 times 21, is that 42? Over, what's the bottom?
It's a difference of squares.
It's a difference of squares, so what is the bottom?
4 minus 21.
4 minus 21, so then that gives us, what's that, 17 on the bottom?
Negative 17.
4 root 21 plus 42 over 17, negative 17.
Is that the answer?
Hold on, I'm making sure we plugged everything in right, because that's not the answer the book has. Which is weird. 2 root of 21 over 2, we did that, right? Make sure we're not missing anything, because their answer is without the plus 42. Trying to make sure we're not missing something. They also could just have a typo. Huh? I think they just have a typo because we have everything right. Right? That's the right formula, correct? Okay. We're going to roll with that they have a typo in the book because that does happen on occasion. All right, so my question at this point, there's a little bit more that we need to do with this section, okay? Remember back what we did in like 14.3 and 14.4, how you were like verifying trig identities and like simplifying them down and canceling stuff out and all that? You know what I'm talking about?
Give me a second.
Wait, did we use the right formula?
Did we?
No.
I have 2 tan A over 1 minus tan squared A. I don't know if we did. You might have had the wrong formula.
That's not what I
Yeah.
So
have.
is that
But hold on, does that also mean
That
that,
we did the last one wrong too.
which job, Josh. Yes, the last one is also wrong.
It's literally okay. That's not even what I have in my notes.
Well, I don't know why it's not what you have, because it's what I told you.
You have to double check what Jess said.
Okay, well, let's just go. Let's finish the problem we're on, and then we'll go back and fix the other one.
It's okay, Josh.
Okay, well, it's not going to change the top of that one, so let's just...
Oh, I have to use some of my eraser.
I have a block eraser if y'all need it. Somewhere in here.
Wait, where are we backtracking
Anybody?
to?
Anybody need a
Yeah.
massive eraser and pass it around? Well, I'm backtracking to basically step 2, where we plug everything in. Somebody check Josh's work now. Sorry, Christian and Peyton. Josh can't read the formulas correctly. I just took your word for it. I was like, yeah, let's go. I should take away cookie points for that.
No.
Yeah.
It's not only my fault. Y'all should have checked.
They believed in you.
Yeah, we were trusting in you.
Do you know how many times I've messed up in this class? You really shouldn't at this point.
That trust is gone.
I mean, it was what you did in the last problem. I was like, yeah, sure. Then I was like, oh, wait, I'm not right.
You betrayed our faith. Sorry.
Okay, so I need to treat the bottom as 4 over 4 minus, so that's going to be 21 over 4 there. Also make the math a lot easier. There's no square root at the bottom. All right, so then that's going to give you square root of 21 over negative 17 over 4. Now, right, is it negative? It's negative.
Yes.
Are we sure?
Yes.
Yes.
Okay.
Negative 21. Plus 4.
Is this negative on top? Y'all just aren't catching any of the mistakes today. I was like, something's wrong. Clearly, today is not meant to do math. That's where we're at right now.
No.
Okay, so back up. That needs to be negative.
So is it?
Okay, so the square root of... Okay, so hold on.
Oh my god.
So sine should have been negative and tangent should be negative.
Oh.
It's only going to change the sign, so it's fine. So then in sine of 2a, it just needs to... The whole answer is going to become negative because it's negative square root of 21 over 5. Today is not meant to do math. That's why tomorrow's field trip day. That's just where we're at.
Yeah, I think we just need a breather.
Okay, so then this one, it doesn't really matter because the negative would have become positive anyways there because it would have been a negative squared, which would have been positive. So that one is fine. So then down here, this should be negative, and then this should be negative. This negative in the squared part is going to go away. It's going to become positive. So the 4 minus 21 over 4. The top should be negative square root of 21. This is what happens when you don't do math for like a week on spring break. Though I did do some physics over spring break. Not a ton, but I did do some. Alright, so negatives are going to cancel. There we go. So then, huh?
Do we have to double check?
Yeah, do we have to double
We're
check?
good.
Alright, so square root of 21 times 4 over 17. I mean, y'all could have earned like 2 cookie points on me. You just... It's fine. It's fine. It's just a sign. 4 square root of 21 over 17.
sure if Peyton was here, she would have caught my mistake.
She would have definitely caught that, and I'm pretty sure she would have caught my negative too. Okay, so we need to back up and do the tangent one for the other problem over again. I'm just... All this is gone. All this is
I need
gone.
that erasing back.
I need to erase it too.
I need it also.
This problem will get a whole lot easier. Because the only difference is that the square root of 3 is getting squared now in that one. So it'll just make it a lot easier in general.
Wait, what did you do?
I literally just squared the square root of 3 because it's supposed to be in the formula that way. And actually then, oh,
We have
hold
to
on,
fix sine
hold on.
this one too, right?
No, I don't think so. Hold on, because
Or no.
was our tangent value was negative root 3, so it's minus parentheses negative root 3 squared, so it's going to actually be minus now. So the negative on the square root of 3 that's getting squared is going to be positive, but it's going to be 1 minus whatever that value is. So on top, it's negative 2 root 3
1 minus 3.
over, yeah, 1 minus, this part's going to become 3, so 1 minus 3. So negative 2 root 3 over negative 2, which is just square root of 3. See, math is so much easier. I told y'all this is the hardest section of the book.
Wait.
I was like, do I have something else wrong? Please tell me I don't.
I thought, but I'm really.
Okay, so at this point now I can finish what we were talking about earlier. The stuff that we did back in like 14.3 and 14.4 where you were like verifying trig functions and like simplifying them down, you now have to do with double angles and half angles. Which is where I said it matters which formula you pick. You have two options. There's some time left today that you could start working on the problems. It's only going to be 2 more added to what I gave you yesterday. You could start working on those, whatever. And then we can do the verifying stuff on Thursday, because obviously we're not here tomorrow.
I'd rather do that.
Or I can teach the verifying today, and then you have the whole class on Thursday to work on stuff.
Teach verifying tomorrow. I mean,
Thursday? Okay. So just so you have it. Yesterday I gave you some problems, whatever they were. And today I'm giving you 13 and 19. So I'm only adding 2 to what you had. If you're confused or something, Josh.
Wow. Wow.
Kidding.
I see.
But you're not going to get the formula wrong when it comes to the test. So that's what's important.
Yeah.
But I would do 15 and 17 if you feel like you need to do more after you do those 2. So.